Yeah, so good afternoon, all. It gives me immense pleasure to welcome you all to the inaugural session of online FDP on modern computer vision, which is organized by Department of Computer Science and Engineering and E&ICT Academy, MNIT Jaipur. So in this session, today we have with us Professor Vinit Savla, sir, the Chief Investigator of E&ICT Academy. Sir has joined online. And we have with us our head of the department, Professor Mustaq Ahmed sir, and the co-coordinator of this E&ICT Academy, Professor S.J. Nanda sir. So as you all know that the importance of computer vision nowadays, computer vision is all around us. We all know there are a lot of applications you have been witnessing since last 2-3 decades, including the biometrics, iris biometrics especially, whenever you have registered for Aadhaar card and all. And then followed by a lot of applications in the field of optical character recognition, drone technologies, and to autonomous vehicle driving and all. So we will discuss all these things. So we have arranged, or you can say, designed the course in such a way that will take you through the journey from the traditional computer vision to the modern computer vision. We have with us in this particular course 29 speakers. You might have gone through the list of the speakers. We can say the best among, the best researchers we have collected, right, across the country, not only from our country, but also there are few speakers who are from the outside. And they are the pioneers in the field of computer vision. So I hope you all will learn so many things from them and you can interact with them. After each session, you can ask them queries and you can learn so many things. And you will be, I'm happy to also announce that we have received an overwhelming response of around 150 participants, those who have registered in this course. And yes, I hope that you all will learn several concepts of modern computer vision, its practical applications in real-time scenarios and all. So this now I request our head of the department to share his thoughts on this course, modern computer vision.
Okay, so thank you very much, Dr. Deepak Ranjan Nayak and Dr. Nanda for enlightening that faculty development program. I welcome Professor Vinit Savla for having this inaugural session, though he was too busy in other activities. Pertaining to this faculty development program, which is running in parallel with the other program, which I am as a coordinator in this, and EICT is exhaustively being used in order to provide us a type of that interactive session for the faculty and the research scholar. Pertaining to this visual uh, visualization and use of that extensively nowadays is common. I have seen this while traversing in the abroad that the vehicles are being used without any driver, and that requires a lot of the core machine vision and decision-making criteria while using such type of the devices. And in that case, the most of the challenges are there that how to obfuscate those type of obstacles which may be visualized, which are static or moving part, and making that a decision in the critical time scenario pertaining to that, that is very much crucial. So as Dr. Ranjan has stated that such type of the visualizations and using the machine to provide you the state of art outcome without any collision and the damage, and having that path or route which is in the real time a optimal and the correct one. That is the what the achievement is. So pertaining to that, there's a lot of research that has undergone in the department and the faculty members of our department and the sister and concerned department are doing in this very area. So I hope that the vast amount of the people, as you stated, that 150 plus are already registered, and the eminent faculty from the department and the other institute of India and abroad are providing their valuable input and their research that will not only enlighten you to impart that knowledge, also you will be finding the key areas where you can work. So I hope the best wishes for all the participants for their the engagement with this faculty development program, and hope they will get the useful information for their area of expertise and research work. Thank you. Over to you, Vinit Saura, sir.
Yeah. Now I request Professor Vinit Savla sir to share his thoughts.
I hope, yeah, good afternoon. I thought Dr. Nanda is there, so I was not required. Anyway, good afternoon, all the participants, faculty members, students, and working professionals from all over India. My faculty colleagues, Dr. Nanda, who is coordinator and co-CI of Academy, Dr. Mushtaq Ahmed, head of the computer science department, and of course, the person who has put in a lot of efforts for this program to be in place, Dr. Deepak Ranjan Nayak. Thanks to Deepak, you have worked hard for putting this in place, and I have seen the coterie of speakers, and on behalf of Academy and on your behalf also, I reiterate that we are grateful to all the speakers for having spared their time and contributing to this cause of education. I would also like to thank Dr. Professor N.P. Padi Saab for always having a motivation and trust for all the Academy's activities which we are pursuing there. MNIT has achieved the target of 4,000 trained participants for this year, and we are still counting till March. The more important is the programs are quite quality programs, and the speakers which are taking part are the main, you can say, the contributors to that part. So thanks again to all the speakers, and thanks to Deepak, and thanks to head of ECE for sparing his time. I think Dr. Nanda would like to say something. Sorry. Thank you very much. Happy learning to all the participants.
So now I request Professor S.J. Nanda, Satyasai Jagannath Nanda sir to share his thoughts. I think
So, as mentioned by Professor Vinit Savla sir, that Electronics and ICT Academy is doing very good over in the second phase. Its first phase was started from 2015 to 2022, and now we are in the second phase from Ministry of Electronics and IT, in which we have to train around 14,000 participants over the next 5 years from 2024 to 29 all across the country. The ministry is expecting that we should train the teachers so that the knowledge will be passed on from the teachers to the students. So all across the country, the teachers from various technical institutions, if they get the knowledge in the advanced courses on the electronics, IT, computer science, and electrical engineering, then that will be immensely help to pass on the similar kind of knowledge to the students. So with this particular vision, the 7 electronics and ICT academies that set up at various NITs and IITs and IIITs, they are doing this massive job of training the participants up to the industry standard. And the modern computer vision is one of the MDP fully aligned in this particular direction. In this, several eminent professionals from various IITs and other NITs, these speakers are, and they are eminent throughout the country for their research in this particular field. And in this particular FDP, the participants also do have to attend the FDP seriously, and they have to appear for 2 quizzes in the FDP, and the learning materials will be shared over the Canvas platform, which they can able to download after the end of the lecture. And the lectures, if some participants could not able to attend, they can also view it on the YouTube platform. So the live interaction is also very important for every participant, because the quality of speakers you can see in this particular course, it is very difficult to connect to them in live. So after every session, participants can ask the questions to the speakers, and that will also be immense help for the participants. So this much from my side. I wish a very happy learning to all the participants.
Thank you so much, sir. Thank you, sir. Now I request Dr. Ashish Tripathi. Hello, Ashish sir. He's Ashish sir. Are you there?
Hello.
Yes, yes, sir. Yes, sir. You can share your thoughts, sir, about this FDP on.
Okay. A very good afternoon to all the participants, and I would just suggest that please try to attend all the sessions live and try to interact with all the speakers, because as you all already seen in the brochure, that all the speakers are very rich in this area. They have done a lot of research, so you'll not be able to only get the concepts, rather you can just know about the research and what's going on, and what are the problems that you can also pick for your research in future. So I will just suggest that try to attend all the sessions very seriously,
Yes,
and try to interact with the
Dr. Ashish, Dr. Ashish, from my side, welcome to this faculty development program, and I hope that your valuable input will be very much useful for the participant. And my best wishes to all the participants. And thank you for being as a keynote speaker of this faculty development program, especially this computer vision part, which is very much useful in fact, 3 or 4 research workers, researchers, they have completed the type of that research, slightly part of that which I had already discussed under my supervision and the Nitan and Madam supervision. So this would be a great part of the knowledge shared by the faculty of the eminent of the various institute of repute. So thank you, Ashish, and thank you for inviting me for this faculty development program.
For joining us.
Invited inaugural session. Thank you.
Thank you,
So
sir.
I'll have to go to the another parallel session which is going on. So thank you very much.
Yeah, Ashish sir, you can please continue.
Okay, and that was all from my side. So thank you.
Thank you, sir, for joining the inaugural session. So participants will be having our first session at 4 o'clock, and the first session will be taken by Professor Tapan Kumar Gandhi from IIT Delhi. So before that, let me also tell you something. I think Professor Nanda has already mentioned about the attendance criteria, and also there are 2 quiz tests. I mean, there'll be no such time bound for quiz tests, so, right? Okay, from this to this, you have to attend the quiz, not like that. So we'll open the quiz test for 24 hours, or let's say for 12 hours. So you can 24 hours, minimum 24 hours. So you can attend any time, right? You can attend whenever you are available. Yes, but whenever you will start the exam, so the time duration will be either half an hour or 1 hour. It all depends on right, ask how we are preparing the questions and all. So as you have gone through the flyer, that where you've seen that we have divided all the lectures into 4 different modules. So in the first module, actually, we will talk about mostly the fundamentals of computer vision. You can see the fundamentals of image processing, although the name is so-called modern computer vision, but we have intentionally kept this module just to appreciate, right, the concepts of the modern computer vision. So, and even it is very important for all of us to learn the basics of the image processing, the image formations criteria and all, and including the traditional image processing, which is even currently being used as a pre-processing stage in a computer vision system. So followed by we have another modules on feature, especially feature descriptors, which are also very important because everyone is nowadays talking about feature, right? So even in learning based computer vision, I mean deep learning based or computer machine learning based computer vision. So there also you will find the name of the features, right? Yes, of course there are difference between the traditional, you can say, the handcrafted features and non-handcrafted features. But we should also, I think there are only 2-3 days where we will discuss about all these fundamentals. And then the fourth day onwards, we will start discussing a learning-based computer vision, where you will find the concepts of deep learning, several applications of computer vision. So, and there are a lot of applications also at the end you will find, right? There are applications to hyperspectral imaging, there are applications to medical imaging, there are applications to different field. And there are also a few lectures on video processing you will find, anomaly detection, activity detection. At the same time, you will also find there are sessions on the future of computer vision, right? How the 3D robot vision works. There are also a few sessions on 3D vision. And as I mentioned that we have 29 speakers in this particular course. Out of them, 26 speakers are from the academics and 3 speakers are from industries, especially from Microsoft and Meta. You might have gone through it. So I hope, I mean, it's really very difficult task, right? To arrange the sessions, right? Because there are 29 speakers, you know that, right? So we have tried our best to arrange the sessions so that you can, I mean, sequentially, so that you can understand all the concepts in sequence, right? So thank you very much, I mean, all of you, for joining the inaugural session. So at the end, I must thank you, all the staff members of the A&ICT Academy, my PhD scholars, especially Dipankar, who has helped me a lot. Without him, this would not have been possible. And our director, Professor N.P. Padhi, sir, who has always guided us. Professor Vinit Savla, sir, who has always supported us and also gave constant encouragement throughout this journey. Thank you so much for joining us. We'll start our first session at 4 p.m. sir. The link is same. The link is same, right?
See,
Okay.
please wait just for 5 minutes.
Thank you, Nanda sir, for joining us.
Hello, can you hear me?
Yes, yes, sir. Yes, sir. Yes, sir.
Now
Yeah,
please
yeah.
start.
Yes, yes. Okay. So, participants, we will start our first session. So, namaskar, sir.
Okay.
Professor Nanda, sir.
Hello.
Hello. Yes, sir. Yes, sir.
Yes. Hi.
Yes. Yes, sir.
Hello, Dr. Nanda.
Yes.
Yes.
So you might know him. So he's also a student of Professor Ganapati Panda, sir.
Okay. Yes, that also.
Yeah. Okay, sir.
So,
Sir, thank you so
Okay.
much, sir, for joining us, sir, in this session. So it is my pleasure to introduce Professor Tapan Kumar Gandhi, who is a pioneer in the field of AI and computer vision in healthcare. So Professor Tapan Kumar Gandhi is working as a full-time professor in the Department of Electrical Engineering at IIT Delhi. He's also a cadence chair professor of AI and automation, associate faculty in School of AI at IIT Delhi, adjunct faculty in the School of AI and Data Science, IIT Jodhpur, IIT Dhanbad. He has completed his PhD jointly with MIT USA and IIT Delhi. He has spent more than 3 years as a scientist at MIT USA before joining as a faculty member at IIT Delhi. So he was awarded the first Inspire faculty in India in the engineering and technology category at the Department of Science and Technology, Government of India. During this 5 years tenure, he was awarded the Excellent Inspire faculty by DST, Government of India. His research expertise spans computational neuroscience, brain imaging, machine learning, AI, cognitive computing, healthcare technology to AI. He has published his research articles in top ranking journals and conferences, including Nature, Science, PNAS, Current Biology, Plus Biology, and IEEE Transactions. He has more than 250 publications in international journals and conference proceedings. He has received several awards. To name a few, he has received, yes, as I mentioned, several awards. He was selected for coverage pages and all. He had 6 patents and 3 technology transferred to Ministry of Social Justice, Government of India. He has received Platinum Jubilee Young Scientist Award 2015 by National Academy of Science in India, GYTI 2019 Award, Chair Faculty Fellow, Abdul Kalam Technology Fellowship. He is elected fellow of National Academy of Engineering, elected fellow of National Academy of Science India, elected fellow of International Artificial Intelligence Industrial Alliance, and he's also senior member of IEEE. With this, now I request Professor Gandhi to kindly start his session. We are looking forward to your session, sir. Thank you so much, sir, for joining us.
Thank you, Dr. Deepak, for this introduction. And I think both of you are organizer, Dr. Nanda and Dr. Deepak, right?
Yeah, Nanda sir is also the coordinator of our academy who is funding it.
Okay. Good. So let me share my screen.
In this first session.
Hello.
It is our pleasure to invite you, sir, for the first session of this particular course, Modern Computer.
Okay. Let me share. So I'll just share screen. Allow you to share screen. Continue. So can you please see my screen?
Not.
Can you see my screen?
Not, sir. Not yet.
Now?
We can see your face, sir. Yes, sir. It's visible, sir. It's visible, sir. Yes.
It's visible? Okay.
Yes. Sir.
So, good afternoon, everyone. The title of my talk is Visual Intelligence to Vision Intelligence, the Way Forward. So I selected this title for few reasons, because many of us working on the computer vision, and maybe the computer vision application is in the healthcare or the automation or maybe face recognition. So many examples are there where we use computer vision. So what's the difference between this visual intelligence to vision intelligence? So here, of course, in this picture also, I'm just showing you the same thing, that first of all, that we need to understand that how our vision work and how we can mimic our visual ability to the computational vision. And this is called the visual intelligence to vision intelligence. So vision is basically how machine interprets the images and how machine find out something from it, or how machine interpret and tells you the story. So if I'll show you, this is a very simple example I'm giving you because I want to just demonstrate or to tell you that what are the new kind of insight you can bring to the domain of computer vision. So here in this picture, I'm showing you the picture of a earth. And if I'll ask you, what is the shape of earth? Of course, the answer will be maybe the elliptical, maybe just like a globe. This is what we have studied since our birth, right? But the truth is, the shape of the earth is like this. And this is called a geode. The earth shape is geode. So that means it's not elliptical, it's not like a globe, but it's a geode shape. You can see here, just like it's a mud, I mean, people take a mud and you can see there is no proper definite shape. But finally, if I'll present these two pictures in front of you, what we are doing, we are estimating the shape of this geode to the circle kind of path, right? And this is how the earth, I mean, we as a human, we define the earth like this. So I hope you understood the difference. The original is the geode, and this is the earth which we discuss or we represent in our different kind of map. So likewise, here I'm just giving another example. This is the left side is the human eye, the right side is the machine eye. If I'll ask you, what is the difference between these two? And if you know the difference, the true difference, then you can do wonders in the domain of computer vision. So if you look at these two pictures, of course, I mean, I don't know whether you are allowed to speak or not, but let me give you the difference. Maybe you can think about it. So if you compare these two kind of system, then of course, I mean, if you understand this thing, it will again take you to the deeper insights of artificial intelligence. So here, in case of the human eye, you know, our eyes, simply that just like what you see, you just imagine that you are taking a snapshot of any scenes or you are watching some sequence of events, right? Which is the 3D events or 2D events, whatever it is, but the sequence of event, both in the temporal and spatial domain. And whatever you see, let's say we are seeing many different kind of information since morning to evening. If I'll measure or if I'll collect all the things what you see or around experience around you, maybe it would be terabytes of data. But out of all this thing, you hardly use all of them for your everyday life. Maybe you use some of them. And from this concept, we get the concept of called the cognitive computing, right? But here, in the case of the computer vision, so what it does, it process each and every information, mostly each and every information. That means they process demanding task, right? Second is, here, the computer vision, whatever we have today, it has no ability to create the story out of it. Let's say, as a normal vision, if you see something, you can tell a story about it, right? Or you can create a story in your brain. But the computer vision, this kind of ability is not there. So if you know, if you have seen some of the newly ads given by the iPhone 17, have you seen in many airports also, you will see that there they have written the tagline is vision intelligence. Vision intelligence, what does it mean? They have tried their best to bring the human kind of interpretation to the machine. That means if you are buying iPhone 17 or maybe the advanced version, that iPhone has the ability to make a story or to tell you the story, not only the image, but it can tell you different kind of story out of these images, the way you visualize or the way you make the story, right? Then the third thing is that in the machine vision or this machine vision which I'm showing the right side, here you can increase or decrease the number of sensors, whereas in the human we cannot increase or decrease whatever is being done by the nature, those number of sensors will get. So that's why you know that sometimes when we cannot see something by our eye, what we do, we take a snapshot and then we enlarge. So there we use the computer vision, the machine vision. So both of these having their pros and cons. But if you look at the natural vision or the human vision, this is the natural one, the original one. Just like I have shown you the geode and the earth, the present earth, how it looks like. So the eye is the geode, that means the original one. And the computer vision based one is the what we have created, right? I hope you understood the difference between these two. So here I'm just giving you another example of that somebody is driving the car, and you know that this driverless car is the new age fashion, or maybe we can say the new age technology which we are bringing to our life. That means you have to just sit in your car and you have to tell your car that where to go, and then automatically this car will take you to your destination. So just imagine that how this car is doing. Of course, the answer will come that the car has many sensors, and based on all these vision sensors, it decides that whether there is obstacle, whether there is any other vehicle, or the light is red or green. Based on that, it will decide which path it will take, right? But just imagine, let's say you are driving the car and you are sitting on the inside the car, or and you on the steering, and just imagine how you drive. Let's say you are driving your car with maybe 10 of your friends, or you are talking to each other, you are laughing, and at the same time you can easily navigate. So just imagine in a fraction of second what kind of different computation happens in brain. And if you can understand all these interesting details of the natural computing, and if we can translate to the domain of computer vision, then of course it would be just like the human. So I always ask this question, that do you think that if I'll bring this autonomous vehicle to India, and do you think that it will work well in India? Most probably no, because all this the automated vehicle or the driverless vehicle, which are all rule based. Even today's world, the AI you are talking about, many of these AI applications are completely rule based. But as a human driver, though we follow the rules, but at the same time, we bring our cognition, our intuition, right? Or our sentient thinking, which we call the sentient AI. Sentient thinking means human-like thinking, that how our sensory system or the perception system work together, and we bring those kind of knowledges to our understanding. And for that, because of all these kind of things, we are better driver. But can we bring those kind of thinking to the car? And just believe me, until now, whatever the car you see, the autonomous vehicle you see, the Tesla, Google, everybody is working on in this domain, but all of them are mostly rule based, right? So this is again the example I'm showing you, that through the sensor, it calculates all the different the vehicles where it is, and both temporally and spatially, and based on that, it takes its next step, right? Again, the same thing I'm just giving you here. The example, the computer vision camera, you know that in industry 4.0, we are talking about that how the robot or the technology is going to take our jobs, right? So actually it is not going to take our job, but actually it will help us the scenario where we fail. Just like if we want to observe any factory or some kind of important installation where the each and every second human intervention required, and the worst part of human is we get easily tired. So if you are doing one job which is very repetitive in nature, we lose our interest, and slowly we'll get tired, and then we commit mistake. Whereas the machine, if you are giving this job to a machine, because this is a machine, it will not get tired, and this is the beauty of the machine, and that's why, and the machine is faster than human, and that's why we are bringing machine in the name of AI to our life, right? But the big question is it truly AI? Or is it truly, I mean, we are bringing the intelligence in some form in the machine, which can behave just like the intelligence system do. So again, here I'm just giving another example. You know that the computer vision in healthcare, just like here, you know the brain, this is the brain picture I'm showing you. So in the brain is a very folded structure, 3D folded structure. So the big question is how we can better, segment gray matter and white matter. So we developed many different algorithms, and then we see that whether this algorithm can do the job beautifully or efficiently or not, right? So here, this is a big question I'm just showing you here. Just like, let's say tomorrow morning, you wake up from your bed, and when you wake up from your bed, you see the beautiful world around you. But just think that one day you will wake up and you see the world around you is completely white or dark or white. How you'll feel? So of course you'll feel that there is something happened to my brain, right? So the big question is, do we know that how we learn to see? So this is the big question in the domain of computer vision. Why? Because we all are interested in computer vision, and we know that computer vision, the artificial one, where we create the algorithms and we then deploy in the machine or the hardware, and then we perform our job. But before coming to this domain, do we understand that how as a human being we execute this job? And of course the answer is no. So that's why it's very, very important to understand both the machine and the natural intelligence, that how it does. Just like here, I'm giving one example that somebody, I mean, here this is apple, and when you see the apple, the rays of light enter to this eye, and from this eye, the light energy convert to the neural energy, and this neural energy go to this lateral genicular nucleus, and then finally the visual cortex. In this entire path, how this rays of light is being converted to the neural energy, and finally we see as an apple. This is a very big mystery in the domain of science. Let's say if I'll show you two different apple, again your vision system is very, very expert to understand. But do we know the science behind it? And if we know the science behind it, then most probably this would be the ideal way to convert this fundamental science to the technology and to create we can create the computer vision which is very similar to the natural vision, but actually we are far from this kind of ability. Here I'm just showing you all this object, right? And all of these objects are different, and only the rays of light is coming to your eye, and finally we distinguish this is a car, this is a bus, or this is a helicopter. But the question is how or what or which part of your brain or the eye is deciding that these are the different elements. So these are again, the different computer vision applications that using some algorithm you can do it very well, but still there are lots of challenges. So challenges is in many ways. Let's say if I'll talk about the facial identity, this is also a big challenge, that how we recognize somebody known, somebody unknown, and somebody maybe celebrity. So these are all big question of the science. So here again, this is a very interesting computer vision application I'm showing you. You must have heard about bionic eye. Bionic eye means, let's say many scientists around the world, they're working to restore sight to the blind. That means those who are born blind, that how they can see the world, right? And here this is a gadget, and this gadget was developed by some scientists at the Washington University, the red color guy you can see here. And now the person who is wearing this glass, he is a blind person, and in front of him, one lady is standing. So this person is telling that first time in my life, I can see my wife. But here, this is not the truth. The truth is something different. The person only can see the phospins of his wife. That means only the dark or light patches, and most probably the boundary or the contour of his wife. But he cannot see the way you or me, we see the world, right? But still, I mean, these are the assistive technology. So at least, I mean, if somebody can see even the contour of his wife, this is also a big thing, right? But the big question here is why the person is not able to see his wife the way we see. Because here the big challenge is, here I'm just showing you this example. This is the eye. From the eye, the range of light is going through this pathway, this optical pathway, and from here, this is the lateral genicular nucleus, which is very close to the brain. And then from here, there are some different fibrous like structure, or the very big band of fibers which is going to the back part of the brain. And this back part of the brain, V1, is called the visual cortex. And after reaching here, we see some object, right? So the big question is, do we know that how the picture is being converted to the light energy, finally it's to the neural energy, and finally this neural energy converted back to this, object recognition task. So this is completely unknown to the scientific world, and that's why as a scientist or an engineer, we are not able to develop the bionic eye, the right kind of bionic eye, which is one kind of, I can say, the interesting application of the computer vision to restore or to help the blind to see. Again, here I'm just showing you another example. Here, this is the robot and a child, right? And you'll be you'll be surprised to know that today's the most sophisticated robot is again not superior than a 2 years old baby. So even 2 years old baby is much more superior in terms of processing and creating some kind of sense out of what we see, right? So let me show you another example, not this one. So here I'm just giving a small example because this is coming in the domain of, again, we use the AI or many different sets of AI in different way to create the intelligent system. So you know that the first we started about this neural network, which mimics the true representation of neuron. Let's say this is the biological neuron, and understanding how this biological neuron work, we created the artificial neural network, and this is called the perceptron model, right? And here the interesting thing is that you just see here, so this is the engineering neural network, and you can see here this is the weight W1, this is the input X1, X2, X3, Xn, and this is coming summation of X1 W1, Wi plus B. B is, you know, the bias, right? So here the question is, what is bias? Bias means when we don't achieve the 100% of the, I mean, what we want, then we use the bias, that how to mimic the natural one, right? And this happens through the control loop, feedback control loop. So this B, because of this B, okay, this B we want to try to manipulate to bring to the near natural level. But again, we are far from the near natural level. So again, here you know that all of this knowledge comes from the human brain. So again, when we talk about the AI, so AI is inspired from different things, but mostly the deep neural network, which you know, which is the hero of today's world, this DNA is inspired from the human brain, only from the human brain, not from other natural objects or natural living objects, right? So the scientists understood that in the brain, there are not only one or two layers are present which process all this information, but rather than there are many layers which accomplish the job in a very optimal fashion, right? So all of this layer, you know, that they process different sets of information, and finally we see the object what we see. But if you look at this neuron, the left side is the biological neuron, the right side is the engineering neuron, and you can see there is a huge difference between two sets of neuron. So the biological neuron is, you can see, very complicated in nature, but the engineering neuron is very simple. Biological neuron, they, they change their connection each and every second, I mean, even the fraction of seconds. But here, it does not work like that. So that means we are actually, though we are mimicking the natural neuron, but we are very far from the working principle of the natural neuron. So that means the domain, I mean, the AI, whatever we are using today, actually this is not the uh, right kind of things we are doing. I mean, we are far from the natural kind of intelligence. Okay, these are all restricted intelligence. Um, so for this, in order to be good in computer vision, so you need to understand how as a human we process all this information system, because actually though we see in our eye, but this is not only the decision given by the eye, but maybe other sensory modality also plays a very big role, like touch, like tongue, nose, ears. They all together come to, I mean, come to execute the task. Let's say when you see something, maybe also you can hear, or maybe you are touching it. So this is called the multimodal sensory fusion, right? So sometimes, I mean, though we rely on the eye, but also maybe other sensory modality also plays a very important role. But how all the sensory modality, maybe partially or coming all together, play important role, still it's not clear to both, I mean, both the fundamental scientist or the application scientist, right? So that's why it's very important to understand how the information is coming and how we sense all this information, and then how perception occurs in our brain, and finally cognition. If we can understand all this important aspect of our life, then most probably we can come up with the right kind of computer vision algorithm or computer vision technology. So let me give you another example. So I'm not going into details of all this thing. So for the sake of understanding, let me just show you. Okay. So not all this thing. So actually, these are the things of my work. Actually, I try to understand the human brain in different ways. So one of my project is it's restoring sight to the blind. I restore sight to the blind, those who are born blind. Then I track their vision development, how they learn to see the world. So the way they see the world, I try to mimic those kind of principles in the machine. So let me give you an example. So here what I'm showing you here, this is the blind person who was born blind and being blind for several years. So at the age of 21 year, when he became 21 year, that time we restore sight to this person. Not only this person, we have restored sight to more than 700 blinds in India. And again, actually, I'm not going to details. So we went against a Nobel Prize winning hypothesis uh, that earlier actually the understanding was the blind cannot see. First, we proved that the blind can see, and then we try to understand how blinds are learning the visual skill. So that is helping us in a very big way to understand the vision, both the natural vision as well as the computer vision. I'm giving one example. I'm going to that example straightforward. So this is about not this one. There are many examples, but I'm going to the very interesting example here. So how we perceive color? So actually, this is a very interesting study we published in Science. So Science, you must have heard the journal. So this is a very the top-notch journal in the world. So if you have a paper, I mean, I'm telling all the young people that you are attending my lecture, please remember. So always try to read good journal. And if you have one this kind of journal in your profile, then nobody can stop in the world. So you are recognized everywhere that the one of the best scientists. So this is more than if you're publishing 100 multiple transactions, but this is much more powerful than this science paper. And you can see, I'll demonstrate to you just doing simple thing, very easy to go simple things. Still, you can publish in the Science. Okay, so this is a work we have done on this the Indian blind children. So what I'm just showing you here. So this is about the color perception. So color perception is again very important ability what we humans have. But interestingly, what I'm just showing you here, this is how we develop the color perception as a normal human being. So you can see here the left side picture is when the newly born baby born. So when we take birth, that time our color perception is very grayscale kind of. And along the development, you can see here 4 weeks, 8 weeks, 3 months, 6 months. This is how the achromatic information added to our uh, architecture, and finally we see the color images, right? This is the developmental trajectory, and when the child takes a birth and when they become adult, like this is how the color perception progress. And I'm not going to details the eye, so just let's jump to the other things. So in the eye, okay, let me show you. Okay, in the eye, in this, you can see my cursor. This fovea plays a very important role for the color perception because the fovea contains the sensor, rods and cones. So cones are the sensor which is responsible for the daylight vision and rods for the night vision. So that at the night we cannot see in the color during the moonlight, right? Because the rods are get activated. But in the daytime, when you saw something, then you can see the color because the cones. So that means cones are responsible for the color, right? So this is what I'm showing you. The cones of the newly born baby, let's say when you take a bath, that time when you are born, that time the cone size is like this, very fat. But when you become the adult, like then it becomes very thin. So when we are child, that time our cones are very fat and they are not tightly packed. But when you become the adult, you can see the right side is adult cone which are very tightly packed. This is how our architecture develops, right? So this is what I'm showing you. These are the pictures. The color, I mean, this is the left side is the color picture and the right side the grayscale picture. So what happened? Okay. So initially, I mean, we created the database. We took this database, image and database of the color picture, and we converted this color picture also the grayscale. Then what we did? We presented this picture, both the color and this color and black and white picture, to a normal kid. Let's say, if I'll present this picture to a 10 years old or 15 years old boy, they can easily tell ki both in color and the grayscale, ki dog is dog and banana is banana, they can do well. But when you restore sight to, let's say, 20 years old person, and we tested all this both gray and color images, and this is what the result we found. So what you can see here, I've written control means those who are normal, and Prakash subjects I've written means those who are born blind and we restore sight to them, right? So what we noticed, the person who was born blind and they can see later part in the life, we found, they can easily understand color images, but they have difficulty in grayscale image. And you can see here, this is the main difference. Control are both equally well, both in the both cases the images, but in case of the blind subjects, they face the problem in case of the grayscale compared to the color images. So here, one question came to our mind that why this is happening, right? Why the blind, they are already 21 years old, they are good in color images, but why they are not able to do better in the color images, grayscale images? Then what we did, so again, I'm just, to create a basis or the fundamental in you. So what I'm showing you here, as I told you, that the child take a birth, that time the cones are very fat and they are not well tightly packed, only few cones are there. And that time, the nature has organized our vision in such a way that only we will be able to see the grayscale image. That means only the grayscale image there. And along the developmental trajectory, when you will age, that time the cones will become mature, the cones will be tight and thin. The same time, the chromatic information get added, and that's why we become robust in color perception during the adulthood, right? But in case our children, those who are already adult, that means their architectural already been developed, and that's why they're good in color, but actually they didn't get a chance to add all this chromatic information step by step in their growth period, right? So in order to understand this mechanism, what we did, we took a AlexNet network, this is everybody we use, and then we trained this AlexNet network based on our understanding working with this blind and how the normal vision develops, right? So what we did, we divided the training paradigm into two halves. So generally, that you train the model. So we take the first half and second half. So in the first half, we have taken different kind of images. C to C means we train the model with color to color, but only the color images. Second one, only the grayscale images. Third one, first we train the system with the grayscale image, then second we train with the color images. And the fourth one is color to gray. That means we initially train with the color images, and then the second part we train the grayscale images. So here, out of all this training paradigm, so this gray to color, this is the natural way of development. The third one, you can see my cursor, this is all of us, we developed through this procedure, initially the grayscale and then color. But in our case, the blind children, those who started seeing at the age of 20 years, they started from the color images, this one. So when you train the system, what we found, you can see here, the x-axis represents the hue rotation. So hue rotation means when the way you trained and the way you testing, right? 0 degree. So what we found, you can see here, only the case of gray to gray and gray to color, we are getting 100% accuracy. But in the other cases, the accuracy is decreasing when the hue rotation is changing. That means when you train our system, also in the different format, also here the system also giving the good accuracy when they train the system with the grayscale followed by the color images, right? That means what we found from this study, we found both from the computation with the machine as well as from the biology, we found that just like if I'll talk about the biology, that we starting with the grayscale and going towards the color will make our system robust, and the similar kind of things we observed in the machine. Okay, so that means the AI system, if we are developing the AI system inspired from the biology, the natural intelligence, then it will do the better job, right? So this is the paper we published in Science magazine, right? So here at the end, what I will tell you, so there are many examples are there. Uh, if you want to take a really very big jump in this domain, so you have to understand both the fundamental science, fundamental how we as a human being or as a animal, how we process the visual information, and then it will mimic in the machine, then you can do wonders in this domain. I hope you get the essence of my talk, right? And if will do good work, automatically everything will follow, right? So some of this, these are the highlights of my work published in Science, Nature, Times Magazine, Harvard MIT News, many Indian outlets like the Hindu, the Wall Street Journal. This is some of the story covered from my lab at IIT Delhi. The Netflix also created a documentary from our lab that how we are understanding all this, how the blind children start learning this visual skill and how we are mimicking the machine. And in that way, you can create the sentient visual system. Okay, the true kind of near normal kind of AI system for the computer vision applications, right? So thank you very much for your attention. And okay, here I'm just showing you one book at the corner of this slide, artificial intelligence and machine learning. So we have written this book and it's available in both Amazon and Netflix. This is a very, very good book for the academicians if you are learning AI and ML, right? So if you get a chance, you just go through this book and it will help you. We have given many problems, and also we are coming up with 2 series of another book which will help to build very strong background in the domain of AI and machine learning. Thank you very much, and if you have any questions, I'll be happy to answer your questions. Am I audible?
Yeah, thank you very much, sir, for your wonderful talk, for sharing your view. So participants cannot directly interact with us; they can only write in the chat
Okay.
box.
Okay, so you can tell me what were the questions. If any questions are there.
I think can check the chat box. Yeah, so there are a couple of questions in the chat box.
Any questions?
Yes, sir. Can you check the chart box, sir? Light.
Okay, let me
light
the slide.
light energy is converted to neural energy. What does it mean?
Oh, okay. See, when we see something, this is I'm talking the basic physics. So in the physics says that, so if you look at the physics, that only the photons, I mean, people ask you how you see an object. The answer is you see an object that the light comes from the object to your eye. When it falls on your eye, then only you see. So when it is coming, these are the photon energy. And then when it is coming to the eye, so I cannot tell you what is it. So I is sending this information to your brain. That means the light energy is converting the neural energy. This is what I'm talking about. Yeah, so let me, okay.
Yes, sir. There are other questions like, sir, how can we use the multimodal learning to improve vision?
So improve vision means you are talking the human vision or computer vision. So let's say if I'm talking about human vision, then the kind of blindness or the eye problems I'm talking about. But in terms of the computer vision, so the understanding human vision. See, when you see something, this is not only you see. Sometimes what we do, let's say I'm holding something, I can get the feel through the tactile part, right? Let's say you are seeing a lotus, right? Same time also you try to feel that how it smell, right? These are called the different kind of sensory information I'm taking. And when you integrate all this sensory information, your visual perception also changes. And why I told this multimodal information is very necessary, because in the engineering domain, we are not only doing this very vanilla kind of computer vision, we are going to the more experience driven computer vision, right? We industry need. And for that, you need the understanding of all this, that how this different kind of sensory modality plays an important role. That's why this multimodal learning is very, very important to advance that domain of computer vision. Can AI replace teacher? Yes, in certain sense, AI can replace teacher where you need the only routine kind of job, right? You know the difference between AI and the natural one. AI is always artificial, right? If I'll ask you, can your sugar, your artificial sugar, can replace good? Of course, the answer is yes, as well as no, right? And I hope you get your answer. So why the accuracy is 100% when converting gray to color? Why not in others? No, this is not I'm talking the color or gray. I'm talking about, I just mentioned about that how as a natural vision, that means human, how it develops. And then I presented to you a case of that how we can develop the AI system which will follow the humankind, and then it can be the robust one. This is what I've told, right? what kind of research we can do in CV, computer vision. As I told you, that try to understand the science behind it. As a human being, how our vision work, and can we mimic these kind of things in the machine. These are the completely advanced domain of research. What is best approach? As I told you, actually, for me, best approach is to work parallelly in the both the things, both computer as well as the human. Yes, here the neural energy means the electrical signal. Yes, everything happens in the domain of electricity, whether the ions or the electrons. Actually, these are the different kind of terminology, but everything, I mean, without electrical activity, electrical signal, you cannot do anything. For conversion, either G to C or C to G. As I told, G to C, these are training methods, gray to color or color to gray. If you are training your system, let's say if I'll ask you make a computer vision system which can recognize the objects, and if you'll start training your system with a gray scale, then color, that would be much more robust, right? Then color to gray. So training grayscale images first, then same images with color images, can machine learn better? Yes. This is how the machine learns better. So you know that 99% people, what they do randomly. They don't have this understanding, right? But that's why I mentioned that it is better to understand the natural one, because always we are mimicking the natural one. I hope you understood my answer. So if it's done, then Dr. Deepak, if you allow me, I'll take the lead, because I have another class at IIT from 5.
Yeah, yes, sir. Yes, sir. Yes, sir. I think almost all the queries have been answered properly. Thank you so much, sir, for joining us in the inaugural session, and I mean the inaugural talk. I once again, on behalf of E&ICT Academy and Computer Science Department, thank you for accepting our invitation and sharing your valuable time with us. Thank you, sir.
But actually,
thank you so much.
can I give some feedback for you? So actually, for this academy, you can write to this IIT Roorkee, right?
Actually, there are sir, six academy. I mean, 7 academies we have, including IIT Roorkee. MNIT Jaipur is also one among them.
So, but actually, I believe that it's better to have the offline, because online teaching is also not interesting, and also same time in terms of understanding also very difficult, right?
Yes,
So always offline is good. Online we are doing, and participants use to get a certificate, but this is not the right approach for the learning.
yes, sir. Yes, sir. I mean, we will take up all these suggestions, sir.
Yeah.
In the next FDP, we will try,
I know.
because
This
there are a lot of
this FDP is online mode. I know. So
yeah. I mean, we
okay.
have actually, sir. We have. I mean, we can organize it in offline mode. The only thing is the kind of speakers which we have collected. They are all around the world, so that's
Yes.
why we face difficulties. Next time,
Right.
definitely, sir, we'll take up your suggestions and all. Thank you. Thank you so much,
Okay.
sir.
Okay. Thank you. Bye.
Yeah, participants, we'll start our next session. It's our 5:10, just after 10 minutes.